Alrighty. So, chapter 4 promised a video, and here it is. We're going to do this from the beginning. I'm going to try and keep this brief. I'm going to power through a lot of this information. A lot of it's just remembering terminology, so let's do the best we can to quickly take note of everything. If you're taking notes, be sure to write down anything that's emboldened. Okay, so I'd like to keep this video relatively short. Alright, so objectives for today. Define the primary cables used in wired networking. Describe the major types of fiber optic media, and explain the technologies used for wireless networking. So, defining the primary cables used in wired networking is kind of a general way of saying that we're going to actually look at not just the cabling, but also some of the definitions and terminology used in what's known as a cable plant, which is all of the cables in a network. Okay, so we're gonna power through this as quickly as we possibly can. I'm going to give you a lot of definitions, a lot of new terms. You need to remember what these mean and sort of have a theoretical understanding. So we're going to look at a lot of graphics as well. So, okay. So, of course, wired networking, this just means that it uses tangible cables, right? A piece of, cable with wires inside that cable. And in the case of fiber optic, glass, strands of glass are the medium that's actually used. So, with fiber optic cabling, you of course have light as your sort of the means of creating the signals are light signals, bursts of light, and you have with copper wire electrical impulses. And we've talked about baseband and broadband a little bit. For the most part, we're going to be looking at broadband technologies today. There's nothing really that we discuss today other than coaxial cable that uses broadband technology. And even in what we talk about, it's talking about coaxial cable in the days of daisy chains, which would have been baseband signal. So, again, main difference between the two types is the composition of the medium itself, glass fiber strands in the cable rather than copper wires, and the composition of the signals. So that would be electricity or light. And a couple of other differences between copper and fiber optic, and the reason why fiber optic is gaining in popularity. It can go a lot, signals can travel a lot further, a lot faster. So, okay, so the bandwidth medium, so some criteria for choosing network media. First of all, bandwidth rating, so how fast it's capable of going. So with copper cabling, the maximum speed, depending on the category which you choose, is going to be 10 gigabits per second, and with fiber optic cabling, depending on the specific type that you use, you're going to get upwards of 100 gigabits per second, so about 10 times faster. Now that being said, typically you want to choose something that's capable of growth. Category 6A cabling is capable of going up to 10 gigabits per second, so that's becoming kind of the main go-to for copper cabling, Cat 6A, UTP, and even STP in some cases. So a big factor determining bandwidth is how bit signals are represented on the medium. So of course, the faster a bit signal can be encoded onto the medium, the faster that the data is going to travel. And this is going to be determined in large part by the network interface cards as well as the interconnecting devices. So if the NIC is rated for 10 gigabits per second, then the cable must also be rated for that as well. But the NIC is going to decide the speed that it encodes data onto the line. So some cabling, if you use the wrong type of, so like if you're trying to use category 3 cabling to run, let's say 100 megabits per second or a gigabit per second, it's not going to actually function at that speed. It'll try to encode at that speed, but the cabling can only carry at a certain refresh rate, so measured in megahertz. So the signal itself won't be able to transmit at a high enough speed because it won't be encoded onto the cable fast enough. So Again, when possible, choose a cable standard that's compatible with not just the speed you're using, but also the next speed up so that you're capable of growth. So category 6 would be typically what's used in modern networks. Though I say typically, it's sort of a toss-up between Cat 5e, category 5e, and Cat 6. But we'll look at the different categories a little later. But next you have the maximum segment length. If you're choosing, and before I move on, bandwidth rating for fiber optic is also going to be capable, again, of much, much faster speeds. So if you're deciding between copper and fiber, depends on how fast you need the line to go. Maximum segment length. So how far apart are the two devices because of the problem of attenuation? This is when a signal weakens beyond what can be read by a receiving device. So it's no longer a viable signal when it gets to the receiving end. That's known as attenuation. I've talked about that. I've mentioned analogies. If I'm on one end of a football field and I'm speaking at this level, the sound waves will actually weaken by the time they get to your ear, the receiving device, to the point where you can't understand what's being said. So you might hear me, you might hear me talking at 100 yards, but you won't understand what I'm saying. So the same thing kind of happens with cabling, that happens with light, that happens with electricity. Anything traveling through a medium is going to attenuate, and it also happens with airwaves in the case of wireless, if you're using wireless as your medium. Okay. So your maximum segment length is going to be an important factor. There's several different types. When we look at the different types of cabling, you'll see there's quite a different variety of maximum cable lengths. Typically, with unshielded twisted pair, the maximum length is going to be 100 meters. And when picking your cabling, you want to consider 100 meters with 10 meters on either end. So really, 80 meters would be the maximum length for a run of cabling that's within walls. So we'll look at that. That's known as horizontal cabling. We'll look at that in just a minute. But that's where any intermediate devices such as wall jacks and patch panels and everything else would be a part of the total cable length. So you need to consider that as well. Also, if you're in a particularly secure environment and interference or eavesdropping is a problem, so interference would be from electromagnetic interference or radio frequency interference in the case of wireless signals, and eavesdropping could happen on copper cabling, it can happen on wireless signals. It can't really happen, at least not directly in a fiber optic line. So you can't use non-invasive equipment to eavesdrop on a fiber optic line. So eavesdropping and interference would not affect fiber optic cabling. Where electromagnetic interference would definitely affect copper cabling, even if it's shielded twisted pair, even if it's shielded copper cabling, and radio frequency interference would affect wireless signals. So, and of course, you can eavesdrop with either one of these. So it's easier to eavesdrop on wireless signals because, of course, you just have to have a laptop and a small amount of technical ability to eavesdrop on wireless transmissions because, of course, they're broadcast out in all directions. Where with eavesdropping onto a copper wire line, that becomes a little bit more of a challenge, but it can be done non-invasively, meaning you don't actually have to cut into a wire to eavesdrop. And if you want to eavesdrop on fiber optic media, you'd actually have to splice the line and put in some kind of intermediary device for that to be possible. So that's where it helps to be a little bit more secure. Now you also have the problem of crosstalk. That's a type of interference where wires within a single cable or wires within another cable that's very close to your cable actually interfere with each other, because anytime you send an electric current through a copper wire or any kind of wire, any kind of medium, it creates an electromagnetic field around it that's actually a slight amount of can cause a slight amount of crosstalk. So crosstalk is, again, interference when one wire generates on another wire. Both wires within a cable bundle. So, and in fact, possibly across multiple cables in a larger bundle. Okay. I mentioned electromagnetic interference and radio frequency interference, some common sources of EMI: motors, transformers, fluorescent lights are a big one, ballast, anything with a ballast in it, which includes fluorescent lights, and power lines, if they're really serious power lines, can cause EMI and RFI as well. And RFI is usually as a result of other radio devices that would be transmitting signals on a similar frequency or the same frequency. So RFI is usually caused by other wireless access points on the same channel. Microwaves are a big cause of wireless or RFI, and cordless phones, not cell phones. Cell phones are on a completely different frequency, but cordless phones interfere with 5 gigahertz networks typically. Okay, and of course, fiber optic is not susceptible to interference or eavesdropping. Okay, and the final criteria well, I guess maybe not the final criteria, but another important criteria for selecting your cabling is the grade of cable. So when you're talking about different kinds of cabling, it must be rated for where you're using it. There's a couple of different ratings: CMR, CMP, and CMX. CMX is for outdoor usage. There, hopefully you can see that. That's CMX. So that's for sunlight resistance. CMR is for use on a riser, meaning you can use it anywhere that's not inside a wall or inside of a crawl space, called a plenum. A plenum is the area between a true ceiling and a false ceiling. True ceiling being your roof, what's underneath your roof really, and the false ceiling being the actual ceiling of your house. So also known as an attic or crawl space or drop ceiling or something to that effect. But that area is known as a plenum technically. So the CMP is for cable, communication cable plenum. So that's what it stands for. But UTP is typically what you're looking at when you're seeing those labels: CMR, CMP, and CMX. And again, CMX is for outdoor rating. It's mostly an issue of fire safety. I have used CMR in plenums before I was aware of the fact that you're not supposed to, and never had a problem. But typically it gets a lot hotter in crawl spaces, and if you melt the sheathing around your wires, that could cause them to be exposed and arc and do different things. So there is some aspects to the danger of it. So just be aware of whether or not your cabling is rated for plenum use, riser use, or outdoor use. So if you get CMX outdoor use rated cable, you can use it anywhere. If you get CMP, you can use it in a plenum or a riser. If you get CMR, you shouldn't use it in the plenum. So that being said, most people don't look at this information and they just go ahead and wire it. I'm totally guilty of that exact thing myself. So. And then, of course, the final criteria is your connection hardware. If your NICs are all copper, category 5E RJ45 connector NICs, even if they're gigabit or whatever, you're not going to be able to use fiber optic for your media, or for your medium. So be aware of what kind of connection hardware you have. So if your switches are all fiber optic and your NICs are all copper, you're going to have a hard time getting all that to connect up. So keep that in mind as well. And then some other considerations, not as crucial, but definitely valid. And I would say maybe cost is definitely as crucial, but ease of installation. If it's going to be really tough to get your cabling to work, you might want to consider using another type of cable. So medium bend radius. The bend radius has to do with the amount that a wire can bend around a curve. With fiber optic, it's a significantly larger bend radius. It's about a foot, where with copper cabling, unshielded twisted pair, it's more like an inch bend radius. So that would be the radius of a circle if you went around. Okay. I think you can look all that up, and in fact, I believe these slides do say what the specifics are on that. But the cost and time needed to terminate the medium. So terminations are especially difficult with fiber optic media, and it costs a lot for all the equipment. It's about $100 for all the equipment that you need to do to terminate twisted pair, whether it's unshielded or shielded twisted pair, and it's another, I don't know, $20 to get a kit to do coaxial cabling. So keep in mind the cost of equipment to actually do the terminations. And then the physical environment. If it's going to be, a lot of crawling up into attics and stuff, for one type of media, you might want to switch to like wireless. I've gone this route a time or two, saved myself a lot of hassle. And sometimes you might go with some kind of a hybrid between wireless, between copper, between fiber optic. So a lot of networks nowadays are doing hybrids between several types. So and then testability. This is maybe something that might be worth considering. If a network works in theory, everything plugs in and turns on, but is crippled by excessive errors because the cabling doesn't meet the standards that it's required to meet, then you might have problems. So for instance, you can go past 100 meters, you can go past 100 meters in a length of cabling, but if you go much past 100 meters in a specific length of cabling, you might have a lot of errors. So it works in theory, but it's crippled by excessive errors, so it's very slow. And then of course, certifying your cables. You can get testers that actually will certify your cables to say, not just that they pass and that the signal gets from point A to point B, but that they pass and meet the requirements of that cable. So they actually are passing with, a gigabit link. So testability is important as well. And then the total cost. The total cost is not just the cost of cabling. Cabling is expensive for sure, especially when you start getting into shielded twisted pair and fiber optic cabling. But the terminators for fiber optic cabling are especially expensive, and so are the wall jacks. And Cat 6 is more expensive than Cat 5e. So the cost of everything to do what you need to do and actually meet all the standards for that cabling. So for instance, you can buy RJ45 connectors, which are the connectors used with twisted pair cabling we'll look at in a minute, but you can buy those for Cat 5e or Cat 6 cabling. And the Cat 6 cabling connectors are about twice as expensive. So if you buy Cat 5e connectors and use Cat 6 cabling, you're essentially wasting your money, throwing your money down the drain, because your Cat 5e terminators are going to slow the speed down to 350 megahertz, which is the speed that Cat 5e is able to transmit at. So you could cripple your network by not realizing such a simple thing as you have to have wall jacks, terminators, and everything else match your type of cabling, particularly with twisted pair. So that's an important consideration. Okay, so now let's talk about the different types of cabling. Coaxial, often known as coax. I use that term a lot. Totally obsolete as far as LANs are concerned, so we're going to move right on past that. Okay, but I will say it is used in actually real quick before we move on, it is used in WAN links, so you do see it on occasion, and occasionally you might need to terminate it. We don't do any of that in this class. If you want to know, if you're really curious, ask me tonight if you watch this video by tonight, or ask me at some point and I'll bring in a kit and show you how to terminate a coax cable. It's pretty simple. And then you have twisted pair cabling. This is the most common type of cabling used in networks. There's two types, shielded and unshielded. That's where you see UTP and STP, shielded twisted pair, unshielded twisted pair. This is one or more pairs of insulated strands of copper wire twisted around one another, housed in an outer jacket. Essentially, if I could maybe get a little piece to show you here. Let's see if I can just so happen to have a box of unshielded twisted pair rated for outdoor use on hand. And actually this is pretty expensive UTP because it's rated for outdoor use, but it is Cat 5e. And here's what you have. They're braided around each other, or twisted around each other, not really braided, but, and then the entire thing, as it goes through, all of them are twisted around each other as well. So the twists are really important to improve the resistance to crosstalk and EMI. So that's what the twists are for. And actually the rating has to do in part with the amount of twists per foot or something to that effect. So when you look at different categories of cabling, they rate it not just based on the frequency that it transmits at or is able to transmit at, but also the amount of twists per foot. So there's a number of different things included in the different standards. You can actually read about those. There's an open standards document available online. I can't remember what it's under. It's an RFC. Can't remember what the exact name of that document is off the top of my head. But more twists per amount of length of cable means better resistance to EMI and crosstalk. So I'm going to go ahead and pause there for just a minute, and we will come right back.